Hey everyone, and welcome to this explainer. I've been looking into the state of enterprise tech lately, and honestly, what I found completely changed my perspective on where we're actually heading. For the past couple of years, the whole tech world has been, well, utterly obsessed with large language models. We're all comparing parameter counts, debating leaderboards, constantly asking, okay, which model is the absolute smartest? But here's the thing. As enterprises try to actually scale AI, they are hitting a massive wall. They buy the smartest models off the shelf and then quickly realize they have no idea how to wire them into their daily operations. The true challenge of enterprise AI, it's moved way beyond just picking a model. So today, we are going to explore the blueprint for what comes next, building the enterprise AI runtime. Okay, let's dive right into this roadmap. First, we'll look at the shift to autonomous agents. Second, the cost crisis. Third, building the AI runtime. And finally, number 4, management and the ultimate advantage.
Section 1. The shift to autonomous agents.
So the core thing to understand here is that we are evolving from simple chat tools to autonomous digital employees. Think about the difference between, say, asking a search engine a quick question versus hiring a digital employee who can independently research, summarize, and draft a whole response for you over several hours. It's a huge leap, right? We're moving from just a single tool into an entirely new ecosystem. The focus is no longer just on the brain of the AI, it's on the nervous system that supports it.
Historically, we've all been caught up in this crazy model arms race. GPT, Claude, Gemini, everyone's chasing that top spot on the leaderboard. But the future? It's all about system architecture. The real bottleneck for getting enterprise AI off the ground is system-level resource scheduling, governance, and runtime management. Think of it like a really busy restaurant. Having a world-class chef, which is our AI model, is completely useless if the waiters, the host, and the kitchen manager aren't coordinated. It literally doesn't matter how smart your model is if your system can't efficiently route tasks or secure your data. Because AI agents have pretty much upended the entire computing paradigm. We are moving away from those simple single-turn interactions. An enterprise-grade agent doesn't just give you an answer. It executes continuous autonomous workflows. Just imagine an agent that gets a customer complaint, pulls up their billing history, drafts a refund request, checks internal policies, asks for human approval, and then finally emails the client, all dynamically. It parses intent, uses tools, checks for errors, and even replans if something goes sideways. This is absolutely not a 5-second search query anymore. This is a continuous workflow that might run totally on its own for minutes or even hours. To really unpack this, let's contrast the old and new realities. The old paradigm was cheap and straightforward. You had a single-turn chat that consumed maybe a few hundred tokens. And just a quick aside, think of tokens as the fundamental unit of compute you pay for, kind of like drops of gas in an engine. Well, the new paradigm of autonomous workflows means thousands, if not hundreds of thousands, of those tokens are being burned as the agent dynamically replans and iterates in the background. The computational requirement is incredibly heavy, and it just keeps running. Which brings us to Section 2, the cost crisis.
Now, you might be thinking, wait, what? Above the surface, sure, you see the visible user output, maybe a neat little paragraph that only cost a few hundred tokens. But beneath the surface, there is this explosive growth in background inference computation. This right here is the hidden iceberg that most IT leaders are crashing straight into right now. Agents are running through constant cycles of planning, calling tools, and verifying. A single clean output might actually cost tens to hundreds of thousands of tokens behind the scenes, tying up really expensive GPUs for a long time. The financial math completely flips when you move from simple chatting to autonomous task execution.
In fact, our source material hits the nail on the head here. It says, AI-related IT spending has shifted from negligible to a core cost item requiring fine-grained management. If you're an IT leader watching this, well, this is the exact moment your budget changes forever. AI is no longer just a fun little R&D experiment on the side. It's a massive core operational expense, and it absolutely demands an immediate, rigorous financial strategy.
So, what exactly happens when enterprises try to adopt a flagship model for everything strategy? They immediately hit a cost ceiling. Using a premium model like GPT-4 or Claude for a simple routine task like translating an email or summarizing a quick meeting, it's literally like renting a Ferrari just to drive to the end of your driveway to check the mail. I mean, it works perfectly, but it's going to break your budget in no time. Task-based model routing is absolutely inevitable. We just have to match the size and cost of the model to the exact complexity of the task. Which leads us nicely to Section 3, building the AI runtime. To make sense of all this, we really need to shift how we view the software stack. The Enterprise AI Runtime is essentially an AI operating system. It treats large language models not as the entire product, but simply as the inference engine. And surrounding that engine, the runtime unifies routing, context, memory, workflows, and strict governance.
Now, what's really interesting here is how the runtime sits right in the middle of this ecosystem. It dynamically selects the best models from a resource pool. It orchestrates complex workflows, manages your budget, and actively enforces security protocols between your enterprise apps and the models themselves. You aren't just managing a single AI model anymore. You are managing a living, breathing runtime environment. I absolutely love the traditional computing analogy for this. Think about it this way. Large language models are basically just the CPU or the GPU in a computer. They provide incredible raw computing power. But as we know, a CPU is completely useless if it's just sitting on your desk. It needs a motherboard. The AI runtime is that motherboard. It connects memory, input-output routing, and governance protocols to actually make the engine usable for everyday business operations.
So let's deconstruct this. A complete enterprise AI runtime includes 7 core modules. Right in the center, you've got the LLM inference engine. But around it, you have intelligent scheduling on one side with the model router, and long-term retention on the other with the context manager and memory store. And all of this is glued together by a tool bus for API integration, a workflow engine for coordinating multiple agents, a governance engine for security, and finally, an audit system for traceability. It's the organic integration of these 7 modules that actually determines your enterprise AI competitiveness, not just the parameter count of whatever model is sitting in the middle.
To make that intelligent scheduling a bit more concrete, let's look at routing in action. Say you have a simple translation. You might route that to a smaller local model like Qwen. Routine office tasks, send those to DeepSeek. But when it's time to review a really complex legal contract, that gets securely routed to a premium model like Claude. And for massive R&D projects, the runtime might even orchestrate multi-model collaboration. Right tool, right cost, right time. That is exactly how you protect the bottom line, without sacrificing capability. And this is exactly why mature systems prioritize hierarchical context management instead of just relying on massive, raw context windows. Using the brute force approach, which is kind of like making an employee reread the entire 10-year history of your company every single time you ask them a basic question, is incredibly expensive and slow. The context manager takes a much smarter route. Hierarchical management organizes your working memory, enterprise knowledge, and workflow state, and then dynamically pulls only what is strictly relevant for that specific moment to send to the LLM. It saves a ton of money, boosts security, and speeds up the whole process significantly. Okay, moving on to Section 4, Management and the Ultimate Advantage. Traditional software is highly deterministic, right? You put the exact same input in, you get the exact same output out. But LLMs are inherently probabilistic. There's always a degree of uncertainty. And in a highly regulated enterprise environment, we simply can't tolerate that uncertainty all the time. That's why the AI runtime requires a hybrid dual-engine architecture. It functions almost like a structural bridge between open-ended creativity and strict compliance. So the crucial point here is that we're pairing 2 totally different mindsets. On one side, we have the rule engine. It's highly deterministic. It locks down calculations, access controls, and compliance checks. On the other side, we have the AI agent. It's probabilistic, handling the creative analysis, parsing messy requirements, and generating novel solutions. The AI provides the intelligent recommendations, but the strict rule engines guarantee compliant, reliable execution. For trusted deployment, you absolutely need both. As these probabilistic workflows run, enterprises realize pretty fast that trying to save every single token-level thought of the model is impossible. And frankly, it's useless. The old way of dumping a massive chain-of-thought log is out. The new standard is the structured decision log, which borrows heavily from database transaction logs. Because if a digital employee makes a multi-million-dollar mistake, an auditor definitely does not want to read a sprawling AI poem about how it reached that conclusion. No way. They want a structured log. What API was triggered? What database did it read? What rules were referenced? And who actually gave the final human approval? That is what really matters for traceability. And managing all of this requires treating AI with the exact same financial rigor as your cloud infrastructure. Welcome to the world of AI FinOps, financial operations strictly for artificial intelligence. We are talking strict budget controls, hard quota limits, intelligent schedulers optimizing resource pools, and departmental chargebacks. The entire conversation shifts from which model is the strongest to how much compute resource is this specific task actually worth to the business. When you zoom out and look at the history of enterprise IT, a really clear pattern emerges. Over the last 2 decades, enterprise architecture evolved from ERPs to CRMs to cloud computing to microservices. And as you can see here, the natural, inevitable next step in enterprise digitization is the AI Runtime platform. The competition has fundamentally shifted. It's no longer about owning the smartest large model. It is entirely about who can integrate these inference engines, context managers, and governance protocols into a stable, highly efficient, and governable system.
Which leaves us with this final, somewhat provocative question for every IT leader and developer watching. As you scale your AI initiatives, are you still just deploying models, or are you building a true enterprise AI runtime? The answer to that question will absolutely determine your competitive advantage in the decade to come. Thank you so much for joining me for this explainer. Keep building, keep learning, and I'll catch you in the next one.